Okay, this is section 2.4 on functions, function notation, and the graph of a function. So this should be pretty much review. Maybe have some things that are in a different form. But basically, a function is a relation that pairs each element of the domain with exactly one element in the range. And just so you can remember what things go with what, I kind of like to write these in ordered pairs. So x comma y, domain and range are a pair. In alphabetical order, domain before range, domain goes with the x, range goes with the y. We could also call x the input and the y the output. Again, those work in alphabetical order. And then we have control variable and dependent variable. Now sometimes the control variable is listed as independent. That doesn't really work with our alphabet scheme, but you kind of know what that goes with. Okay, here are two relations between a teacher and a room. The teacher is the input or part of the domain, and the room number is the range. So is this a function? Is there exactly one element of the range for each element of the domain? Well, yeah, each teacher has a room number. So yes. Each teacher is paired with exactly one room. In our next example, we just have a list of points. And if you just kind of go through, the first coordinate are the inputs. And then the second coordinates are the outputs, which are the y's. And let's just take a look. We have an input of 3, -2, 1, -2. Oop, here we have a repeat of our input. Now, do we have the same output? No. So that means for the input of -2, we have two different outputs. So we would say that this is not a function, or no, because -2 is paired with two outputs. -2, 4, and -2, -3. So overall it is not a function. And then we have the vertical line test. I abbreviate that VLT. Make sure you ask your teacher to see if you can use that abbreviation. But it's if you have a graph of a function, the graph is a function if and only if, and here's the abbreviation, so if you see that in the future, IFF means if and only if, every vertical line intersects the graph at most one point. And these vertical lines are meant to represent the x-coordinate. So if that vertical line crosses more than twice, then we have, or sorry, more than once, then we have a non-function because there's more than one value. So this is any vertical line, not just the y-axis. I get this a lot of times on the tests that say, yeah, it only crosses the y-axis once. Well, that's not the test. It's any vertical line will only cross the graph once. So let's determine whether this graph is a function. So if we use the vertical line, let's just put one here. Well, that vertical line only touches once. So it looks like we're okay, but you can obviously see if you draw any other vertical line, we're getting two places. So this does not pass the vertical line test, so this is not a function. Because it fails the vertical line test. Make sure on your graph when you're following or when you're answering a question like this that you put in the dashed vertical line so we know that you've used the test, and then just justify your answer below. Okay, in the next example there is y equals the square root of 4 minus x. So we don't have a graph, we just have the equation, so we need to graph this. T-table is a good option, and I'm just going to give you the values, but you can substitute in. So you have negative 5, 3, 0, 2, 3, 1, 4, 0, and then 5 is undefined. So if we plot those points, there's negative 5, 3, 0, 2, 3, 1, 4, 0, and then over here we have nothing past 4. So it's a square root function, kind of looks like this. Okay, let's check it out using the vertical line test. Drawing a vertical line, yep, it only crosses once, only crosses once, only crosses once, so we're good. This is a function because it passes the vertical line test. So just want to note back up here with the vertical line test, you're just going to have a pass or a fail. So if we pass the vertical line test, that means the graph is a function. And if it fails the vertical line test, a graph is not a function.